Number 25, the volume of air in a person's lung as the person breathes in and out can be modeled by the sine graph. The scientist is studying the difference in this volume for the people at rest compared to the people who told to take a deep breath. When examining the graph, should the scientist focus on the amplitude, period, or midline? So if we want to know the amount of air in the lungs, the volume of the air in the lungs compared to at rest, we would want to focus on the amplitude. And that shows how high the output would be. In this case, volume of air. Maybe if it said how long in between breaths or whatever, that might be period. But when we're talking about the amount, amplitude. 26. Explain how 3 to the 1/5 squared can be written as the equivalent radical expression, fifth root of 9. Power to a power, multiply the inside exponent by the outside exponent. 1/5 times 2, 2/5. Now this is what it's raised to. And this is the root. 3 squared is 9, and the root was 5, so fifth root of 9. You might want to write out in words with a rational exponent. The top is the exponent, like what it's raised to. The bottom is the root number. Okay, 27. Now, like I said, way back when we did this, the I basically works like an X until you get some exponents on it. So now, just like X, I can subtract 1 minus 7i. That is negative 6i. 1i minus 7i, 1 minus 7, negative 6. Then square it. Negative times a negative, positive 36, I squared. Now, you could do this a couple different ways. Maybe you could put those together to I cubed. Maybe you just say, hey, I squared is negative 1. So that makes this whole thing negative 36 xi. We want to find tangent. Hey, it even gave you the formula, the trig Pythagorean theorem. Cosine is negative 0.7. All right. So we got negative 0.77 squared. That's 0.49. Subtract 0.49 from 1, 0.51. Square root both sides. Now, this clearly is not going to be a nice cooperative number. So for now, I'm just going to leave it like this. I want it to the nearest hundredth, but I'm not done yet. I got to find tangent. Now, first off, let's just see whether we want the positive or the negative square root. Quadrant 2 is here, left, up, cosine, sine. Yep. So sine should be positive. Tangent, sine over cosine gives you tangent. So now I'll type this in. Second square root, 0.51. Get out of the square root, negative 0.7. To the nearest hundredth, negative 1.02. All right. The x value of which function's x-intercept. All right, x-intercept. So if you're on the x-axis, no matter where on the x-axis, your y value or your output value is 0. So this one's easy. Here's the output. So the x-intercept for this one is 2. Now for the logarithm, log, oops, I already had a parenthesis in there, x minus 4, second table. So again, when you are on the x-axis, you're 0 high or 0 low, I guess. So your output, your y is 0. There is 0 for this function. Oops. So for this one, the x-intercept is 5. That one's larger. When it says justify, you would say from the table on the calculator, this graph passes through, what did it say, 5, 0? So the x-intercept is 5. And like I said, you know, when you're on the x-axis, your y is 0. So this one has an x-intercept of 2. 5 is bigger than 2. Okay, algebraically find the zeros. Set it equal to 0. 4-term factoring, let's split it down the middle. The GCF here is x squared. Now I have a plus plus, so I'm going to divide by negative 4 to switch it. Pull that x plus 1 out. Hey, that's dots. X plus 2, x minus 2. So x equals negative 1, x equals negative 2, x equals 2. Now for the graph, let's type it on in. So I got x to the third plus x squared minus 4x minus 4. Let's just graph it, take a look. All right, let's see. Let's get this back to normal, zoom standard 6, so it looks more like what it'll look like on here. Let me also try to get the glare out of here. All right, second table. Let's try to get some values here. Negative 3, negative 10. If you do not place a scale on this, then all boxes are assumed to be 1. If you want to go by anything other than 1s, you must put a scale down. So we got negative 2, 0, negative 1, 0, 0, negative 4, 1, negative 6, and then 3, it's all the way back at 20. Now, it did some weird things in there, so let's take a look. So it comes up, goes up above the x-axis a little bit, and then back down, and then we're going to go, see it's going to go through the x almost at 2, so I got to do a sharp turn here. There we go. You know, if this was the Regents, maybe try to make that a little bit smoother. Number 34, one of the medical uses of iodine 31, that's an isotope, a radioactive isotope of iodine, is to enhance X-ray images. The half-life is approximately 8.02 days. A patient is injected with 20 milligrams. Determine the nearest day, the amount of time needed before it is approximately 7 milligrams. So this says every 8.02 days. This is one of the every n day things. So that goes over n. It's the like every 8.02 days. So the initial amount is 20. And then we want to know how long it takes to get to 7. It's leaving your body, so minus, and it's a half-life. So 1 minus 0.5 is 0.5. And that happens every 8.02 days. All right, we got to solve for our base. So I'm going to divide by 20. That gives you 0.35. Yep. And then, again, take the log of both sides. That pops that exponent out. You could use any log you want. Might as well use the LOG one. The LN, though, would work fine. So I'm going to divide by the log of 0.5. And multiply by that 8.02. We want to round it to the nearest day. All right, let's see. 8.02 times log 0.35. Close it all over log 0.5. There's a variety of ways you could type that into. 12 days. Oops, there we go. All right, so I got to isolate the radical, square both sides to cancel out the radical. Now, do that off to the side if you need to. 25 minus 5x minus 5x plus x squared. I'll rearrange it, x squared minus 10x plus 25. So we're going to minus 2 and add 7. Eight times 4 is 32. 8 and 4 combined to 12, but they got to be negatives, so we get 8. 4, justify the solution set. That just means do that check. $16 minus 7 is 9. That one does not check. Reject it. And then the 4. Eight minus 7 is 1. Square root of 1 is 1. That one's good. Seth's parents gave him $5,000 to invest for his 16th birthday. Lucky kid. He is considering 2 investment options. Option A will pay him 4.5% interest compounded annually. Now, just be careful. It's compounded annually. That just means one time a year. If you use that formula and you divide by 1 and multiply by 1, it doesn't do anything. Don't make it harder than it has to be. Just use the regular here. So option A equals A0, 4.5. Oops, just a minute. Let me actually write the 5,000 down here. There we go. Times 1.045 t power. N years, I better use N. There we go. B, and I'll just use B for this output, says 4.6% compounded quarterly. 1 plus r, that's in 0, over n quarterly would be 4 times a year to the 4n power. I almost used t again there. Seth plans to use the money after he graduates from college in 6 years. Determine how much more money option B will earn than option A to the nearest cent. So A, we're going to plug in 6. B, we're going to plug in our 6. Oops. This camera won't stay straight here. All right. 5,000. 1 plus 0.046 over 4 to the 4 times 6. If you know that's 24, just type it in. So I want to know how much more. All right, so let's subtract that minus the other one. How long it would take for option B to double Seth's initial investment. Now, regardless of what the numbers would be, if you just go right to 2 here, that would be fine. And then just start off with the base. What I mean is, and why don't I just calculate that? We'll see what it looks like. That's not that hard to write down. I'm going to have to do that at some point, so I might as well do it now. Now, here's what I was talking about. Regardless of what the numbers actually are here, if you divide and the investment doubled, you're always going to get a 2 there. Log both sides again. Pops that 4n out to the front. Divide by the log and by the 4. Variety of ways you could type this in. Log of 2 divided by 4. I'll just hit enter. Now I'll divide again by the log of 1.0115. 10th of a year, 15.2. There we go.